You ever plug in your phone and just not think about it? I mean, of course you don't. But inside pretty much every piece of tech you own, there's this tiny, unsung hero acting like a microscopic bouncer for electricity. So let's pull back the curtain on this hidden world.
Okay, so the juice coming out of your wall socket is something called alternating current, or AC. It's awesome for traveling long distances, which is why we use it for the grid. But it's also kind of chaotic. It's constantly flipping its direction back and forth like a wave in the ocean.
Now, the delicate little circuits inside your phone or your laptop, yeah, they can't handle that chaos, not at all. They need a calm, steady, one-way street of energy. We call that direct current, or DC. So the big question is, how do you tame that wild AC wave and turn it into smooth, usable DC? Well, it all starts with one brilliant little component.
I want you to meet the diode. It's the key to this whole puzzle. And the best way to think about it is as a one-way street for electricity. It's got a very, very strict no U-turns policy.
So here's the deal. A diode lets electricity flow forward through it super easily. But if that electricity tries to flow backward, nope, it slams the door shut. It's basically an electronic check valve. So how does this little one-way gate help us tame that wild AC wave?
Well, when the AC wave is moving forward in its positive cycle, the diode is in what we call a forward biased state. All that means is it gives the electricity a big green light and says, "Come on through, the road is wide open."
And you can see exactly what's happening here. The current flows from the source right through the diode and onto our device. That positive hump of the wave makes it to the other side, no problem. But what happens when that wave tries to reverse course?
Right, so when the AC wave flips into its negative cycle, the current tries to go backward. The diode instantly goes into a state called reverse biased, and it basically becomes a giant roadblock. It's a hard red light, no entry, period. What this does is effectively create an open circuit. It just breaks the connection. That entire negative half of the wave gets completely blocked. So, just like that, the diode has turned a back and forth current into one that only flows one way. But you know, our first attempt here is, well, it's not great.
And this brings us to the most basic type of AC to DC converter out there, the half-wave rectifier. It's exactly what we just saw, one single diode just doing its thing. You can see the difference right here. The input is that nice full AC wave, but the output? It's just the positive humps. We got our one-way current, which is cool, but look at it, it's super bumpy and it's incredibly inefficient. We are literally just throwing away half of the power.
How inefficient are we talking? Well, the absolute maximum theoretical efficiency you can get from a half-wave rectifier is a measly 40.6%. That means almost 60% of the energy you're paying for from the wall socket is just gone, wasted. That's pretty bad.
And the quality of that DC power is just awful. We measure the bumpiness with something called the ripple factor. Now, for perfectly smooth DC, you'd want a ripple factor of 0. The half-wave rectifier, it clocks in at 1.21. That number tells you that the output has more ripple in it than it has stable DC. So yeah, we can definitely do better.
So naturally, engineers came up with a much, much smarter solution, the full-wave rectifier. The whole goal here is to stop wasting half of that beautiful AC wave. And this right here is the big aha moment. This is the innovative question. What if, instead of just blocking that negative part of the wave, we could somehow grab it, flip it upside down, and turn it into another positive pulse? If we could do that, we could double our efficiency and get much smoother power. And two main designs came out of that idea. There's the center tap rectifier, which uses a special kind of transformer and two diodes. But the more common and frankly more elegant solution that you'll find just about everywhere is the bridge rectifier. It uses this really clever arrangement of 4 diodes. So how does this little diamond of diodes work its magic? It's brilliant. During the positive AC cycle, 2 of the diodes, let's call them D1 and D2, they switch on. They create a path that steers the current through the load in one direction. Then, when the negative cycle comes around, they switch off, and the other pair, D3 and D4, they turn on. And here's the clever part. They catch that reversed current and steer it through the exact same load in the exact same direction. The result is this constant stream of positive pulses, one right after the other. Nothing gets wasted.
All right, let's put these contenders side by side. We've got our simple but wasteful half-wave and our 2 clever full-wave designs. How do they really stack up?
I mean, this table really says it all. Look at the efficiency number.
Both full-wave rectifiers jump to 81.2%, exactly double the half-wave. And check out that ripple factor. It plummets from a super bumpy 1.21 down to a much smoother 0.482. We get twice the power, and that power is twice as stable. Yeah, it's a clear knockout win for the full-wave designs.
But here's the thing. That one-way street principle is so fundamental, it's used for way more than just turning AC into DC. There's this whole family of special-purpose diodes out there doing all kinds of amazing things.
I guarantee you know these. A light-emitting diode, an LED, is just a special kind of diode. When current flows through it in the correct direction, it has this brilliant side effect of emitting photons. It literally creates light. It's the same one-way principle, but it's completely revolutionized how we light our world.
And then you've got diodes that do the complete opposite. A photodiode is designed to sense light. When light particles, photons, hit it, it generates a tiny little current. These are the sensors in everything from smoke detectors to the remote control receiver on your TV.
So the next time you plug your phone in, just take a second to remember the humble diode. It's a simple one-way gate for electricity, but it is without a doubt one of the foundational building blocks of our entire digital world. And it really makes you wonder, right? What other tiny ingenious components like this are hiding in plain sight, making everything we do possible?